What's up, everybody? Welcome to Earth Science. We're going to do abbreviated version of this compared to what we usually do from year to year. But let's look at the water cycle in brief. And I know we did like all of this stuff with meteorology, but then we got to think about what happens to water once it hits the ground. Some of this is going to be review, and some of it will introduce a few new terms. And I think what I'll do on one of the other videos as part of this assignment, I said I'm not sure if I'm going to have a quiz or not. I'll do a quick quiz, but what it will be are these. There's going to be 12 questions. These 12 will be the choices, and then I'll throw in the definition, and you just got to pick the right one. I think if you just work your way through by process of elimination, most people should do pretty good. Shouldn't be too bad of a thing. So let's start, and I'll do some zooming. All right, so let's start over here where we have water going from, say, a lake. We'll do it in blue, or an ocean, whatever may work. That's purple. No big deal. And as it goes from a liquid to a gas, what do we call that? I bet you most of us remember. It's called evaporation. I'll change that to color to red. Oh well. There's one other one that's maybe new for folks. What I'm going to do is draw a happy little tree right here. There we go. It's always kind of bugged me that this is a definition they do in earth science, because it's basically the same as evaporation. These are tree roots. Now it looks like a bird. Anyway, it's always kind of bothering me because it really is evaporation. That's a tree, just in case you can't tell. But if you get evaporation that happens through the leaves of a plant, we have a whole new fancy word for it, and it's called transpiration. Now, it's effectively transpiration. It's effectively the same exact thing as evaporation. Water goes from a liquid to a gas. And when we're looking at big systems, that's all that, in my opinion, we really care about is how much water's entering the atmosphere as a gas. Like, what's the humidity turning to? But it's one of those things that they get a little bit more specific, break it down, and say, if it happens through the leaves of a plant, it's called transpiration. Okay? No big deal at the end of the day. Eventually, these form clouds, and maybe we remember from all that relative humidity dew point stuff we talked about, that is condensation. And eventually those cloud droplets get heavy enough that they fall down towards the sky, which we call precipitation. So hopefully that's all old news, where you can see it a little bit better. Now what's going to be getting closer to the newer stuff is what happens once it hits the ground. Now, I have people do this every year, usually with a colored pencil. We're doing it with a Chemi pencil this year. I'm going to have you trace this line, starting right here with this dotted line. Well, it turns to a solid line. And you might want to unclick occasionally and then start again, because if you make a mistake and you undo it, you don't want to have to start all over. Oh, missed that one. No big deal. If there's little flubs like that, I don't think it's the end of the world. Trace it, trace it, trace it, and it goes right up to that mountain peak. There's a couple funny little things here. It's just showing us the ridge of higher elevation. And then what we're going to do is come down the far side of our view over here. And the reason you color it is it really stands out once you color it. Uh-oh, my tree. We're going to go right through the tree. It really stands out once you color it. It really divides this kind of boring black and white map up pretty well. What we just drew, so maybe I'll write it in blue, if that doesn't change everything else. What we just drew is a drainage divide. Rainage divide. Make it big there so you can see it. A drainage divide. So the idea here is that divides out where water would drain. And if you've been watching all the videos, I showed you a photo of the Continental Divide, photo I took up in Colorado, where it separates out water that flows towards the Atlantic Ocean from water that flows towards the Pacific Ocean. This is that like kind of same philosophy, only on a much smaller scale. Water that goes this way flows that way. Water that goes this way flows that way. These exist on larger and larger and larger scales. We could talk about the Lake Ontario drainage divide, which goes from like Tully and Southern Finger Lakes. That whole bowl all drains down into the Lake Ontario. But we could do it on a smaller scale too. Which water, I'm here in my classroom, which water here flows over towards the Salmon River as the Salmon River watershed and then drains into Lake Ontario? Or which water this way, I think the next one up is Grindstone Creek. Which water flows into Grindstone Creek? And then, yes, to Lake Ontario, but those are separate, so how micro do you want to get in your scales? And where are those divided out? We could find that ridge of high elevation that separates those two. I had Google Maps open. It's closed now. We won't get too distracted. So that's your drainage divide, and that makes the area of lands in here. There's two names we use for this, either a drainage basin or watershed, which is the area of land that's all drained by one system. So this area of land all drains into whatever you want to call this river. This area of land over here drains into a different river. And yeah, they go to the same lake, but they're two separate drainage basins or watersheds, separated by drainage divides. Okay. Some of that hopefully is a little bit old news, maybe just refocused. What this many parts of this unit come to, and it's a part of earth science I find like just fascinating. It's like one of the things I just look at everywhere I go constantly is how drainage works, what happens once the water hits the ground, where is it flowing, and then specifically what has happened since we humans have come and basically cleared all the lands. And yes, some forests have regrown, but if you go back to like 1700s, I was reading a book about Revolutionary War in 1777, and the old growth forests and the size of trees, just unbelievable that they were trying to work around for these wars. We've basically, all of that's gone. And now what is here? Has it gone back to forest? Is it farm field? Or is it a city like Syracuse? And what happens once water hits that? It's different than it used to be. Essentially, it's roughly the same shape of the land. It's roughly the same amount of water. And yes, climate change has altered some of that, but the land is drastically different. So what has happened to change the amounts of these two things that we're about to cover? Basically, water has two choices once it hits the ground. It's either going to enter stream systems like this, in which case we call it runoff. So water on the surface, running across a road, going into a ditch, running down the ditch, into a river, that all counts as runoff. Or it soaks its way in which case we call it infiltration. Which is not just a water term. Like you can infiltrate, if you play Rainbow Six type video games, you infiltrate the enemy base. Infiltration is like working your way down in. Okay. So those are pretty much the two choices. Now, what things can change that? Steep hills, what do you think? Impervious cover. If you cover something with a parking lot, what do you think? You know what I mean? You'll have to use your head and think about some of these. So steep hills is going to be more runoff. Impervious cover is 100% runoff, and that can be an issue, and there's going to be a separate video on that. What else? Vegetation. If you strip all vegetation, like if it's a farm field that completely pulls every plant each season so that it's just exposed soil, that gets compacted and water can't really infiltrate very easily. So you're going to have a lot more runoff, and that runoff can drag topsoil with it, which is bad news. Or increase in increase in vegetation. Plant roots keep the soil loose and aerated and allow the assist water to infiltrate down in. All right. So there's a lot of different circumstances. Now, we're not going to go as deep as we usually do. Like, usually we fill this diagram and write and all kinds of crazy stuff, but because of the nature of this year, we're not quite going as hard. What will be on here? 3 of the vocab words that are down there on the thing, and you can, like, if it works for you to fill these out as I talk, then do it. If not, don't worry about it. I'm not going to be checking that. We'll just do it as a quick quiz. You can take the quiz over and over again, and you guys will all be great. What we have is basically 2 sections that we're going to have to worry about. If we went way down, we could talk about how there's bedrock down here. But if we're talking about just the soil, you've got an area where if you go and take a scoop and pick it up, the soil is going to be reasonably dry. And then if you dig, you eventually are going to get to water. If you've been to the beach as a kid, you've probably done this. You dig a hole, and eventually you hit water, right? And you'd say, look, Mom, there's water. You probably wouldn't say, look, Mom, I found the zone of saturation. But that's what you can say now. Down here, where it's completely soaked, is the zone of saturation. Saturation. Up here, where it's dry, and maybe water's percolating down if there was just a rain or something, would be the zone of aeration. Aeration. And the line that separates those two is called the water table. I know it's hard to see when I wrote right on the line, but I want that on purpose. So you get the zone of aeration, you hit the line that's the water table, and once you're past the water table, you're in the zone of saturation. So if you live off of municipal water like I do, you have a well, maybe a drilled well like this. They drill a big boring down into the ground and pump water out. That's it. That's as simple as it is. And if you're sucking a lot on that, you can get this cone around it. And obviously, the well driller wants to know where's the water table. How does that fluctuate seasonally? I better make sure the head of my well is down below that, down below the water table, well into the zone of saturation. And like, what happens if it rains a lot? What's going to happen to the water table? If it's a heavy rain and a big snow melts, like maybe we're getting this time of year, what happens if it's a summer like this past summer where it barely rained all summer? What happens to the water table? Some of you may have had trouble with your wells. I certainly did. All right. So let's see. Did we cover all this stuff? Water cycle is like just the kind of the term for all of this happening, the flow of evaporation to precipitation and back. Yes. I think we did it. All right. So again, one of the themes, one of the things I really want you to, like, almost experience, if I'm poisoning your mind with this earth science stuff, is think about it when you're walking across a parking lot, when you're walking through a town, especially if it's raining or if it's post-rain. What's going on with that water? Where's it going? This is no longer a forest. Now it's a town, a village of Pulaski, right? What's going on with that water? Where does it hit? Where does it go? What does it pick up along the way? And what issues might that lead to? All right. So, yeah, we'll do this quick quiz on those terms. You'll do great, and we'll talk to you soon.